Hello students, welcome back. In this video, we are going to start building our arena survival shooter, Bot Bash Arena, where we get to control a little robot who's going to survive swarms of enemy drone robots attacking him from all directions. In this video, we'll really focus on two main things. First, our world, and then our player. So for the world, we're going to ask ourselves, what kind of feeling do we want the user who's playing our game to experience? We're going to set the mood of the game here. And with our player, we'll then ask, how can we interact with this world? How do we go about moving through the world and interacting with the objects that are in there? So let's head to our computer screen and we'll dive right in. So I have a web browser open right here, and I am going to use an online IDE, so no software downloads needed. You can, of course, use your own IDE, like Visual Studio Code if you have it installed, but I am going to use vscode.dev. So when I go to vscode.dev, it brings me up to a web-based IDE where I can write all of my code right here. So the first thing I'm going to do is I'm going to open our folder for Bot Bash Arena right here in our web-based IDE. So I'll click Open Folder, and I will go to my desktop, which is where I have my Bot Bash Arena folder, and I will select it. And we will allow, and you can trust this author. You can trust me, I promise. All right, and so what that does is it opens up 8 lessons here, and we are going to work through these 8 lessons through the scope of our game. Each folder in here, for example, lesson 1, has a final completed lesson and a starter lesson. So we're going to edit these starter lessons together, going through and fixing this code up. But if you need it, I have the completed final version. In case you fall behind or you want to double check something or reference something, you can always come right here, find the code that we're working on, and see exactly what it is supposed to look like. So let's keep our starter file open though, because we are going to get our hands on the keyboard. We are going to code along together. Now, before we start this, I'm also going to minimize my browser here, and I'm going to open this file directly. So here is that Bot Bash Arena folder that I have. I'm going to click on it. I'm going to go to lesson 1, and we are going to open up our starter file right here. And so it opens right up in the browser. And this is going to be really nice because any changes we make here, we will then be able to see them directly here. So look at our current state of the game. Well, this is really gross. It's ugly, ugly, ugly. It's like this terrible color scheme. My player moves. I can use arrow keys and A and D, but they're super slow. I can't move in the vertical direction, so I don't know what's going on there. It looks like I've got good spacing over here. There's no spacing over here. Not really sure. Oh, and there goes my player. He's just completely off the screen. They just disappeared. And it kind of looks like we've got some HUDs. Like we got a top HUD and a bottom HUD or heads-up display where we can show some information. And right now it just says game name, which is super generic. So this game is officially broken. We need to fix it. So where are we going to fix it? Well, we're going to fix it over here in lesson number 1. Now, before we dive into lesson number 1 and get into actually writing some code, I want to just overview what exactly is in this file. So we're going to start right here by saying that this is an HTML file. HTML, hypertext markup language. It is essentially the language of the internet. All content, all information that's on the internet is in the form of HTML. Now, we're not going to go over too much about HTML, but just know it consists of tags. So we have a tag, we have a head tag, we have a title tag, we have a style tag. And typically, like if you look here with a title tag, you open a tag, you close a tag. And so there's an opening tag and a closing tag, and you put content inside of the opening and closing tags. So right now the content here says Bot Bash Arena. And if you change that content, the content of the game will change. So I'm going to put, let's see, the art of doing CS in here. And so we'll save those changes. And let's see if I go back over here and I refresh, what is going to change about my game? Right up here, previously it had said Bot Bash Arena, and now it says the art of doing CS. So the title tag here changes the text that appears right up here in the little tab that we're working in. So that's just a nice example of how HTML changes content. But I'm going to undo those changes, Control Z to switch that, because we don't want to name our game the art of doing CS. We want to name it Bot Bash Arena. So let's look at some other tags we got. We've got a script tag. So here's our opening tag. Here is our closing tag. And if you look, there is no content between the opening tag and the closing tag here. So what is the point of this script tag? Well, a script tag is where we're going to put all of our JavaScript code. That is the programming language that we will use in our web-based games. So there's no code in here, but instead we are bringing in a source of JavaScript code. We are bringing in an external library of code that has already been written for us. And this is going to be super, super helpful for us. The library that we are bringing in is called the P5 JavaScript library. And the P5 library is really great for rendering graphics to the web browser, to the screen. And so if we look over here, what are we rendering? Well, we're rendering our player, we're rendering this border, we're rendering our background, we're rendering our HUD and our text. We are drawing all of that content to the screen. We're rendering all of that information to the screen. And the P5 library helps us do that in a really nice and easy way. So we are going to talk a lot about some of the functions that the P5 library has and gives us that we can use to make our game development life here in the web that much easier. So if we keep going on, we've got a style tag, a head tag, okay, a body tag. Oh, look, here's another script tag. So this is maybe where JavaScript is going to go. And if we look, there's a lot of JavaScript in here. In fact, that opening tag, if we go all the way down to here, this is where we close that script tag. All of that code in between those two script tags represents our current game. It's this game right here. And so this is where we will edit all of our code. So let's go and look at what's inside of this second JavaScript tag. So our first one imports the P5 library. Our second script tag is where we do all our work. So we've got a nice little heading here for our lesson, Bot Bash Arena Lesson 1, the world and player. And then we have a mission checklist. Each lesson is going to have 8 missions that we are going to go through and solve together. And in solving these 8 missions, we are going to take this terrible version of this game and make it much better, a playable version. Now, if we go just down here, we enter something called the student edit zone. This is safe to modify. Inside of the student edit zone, we have a bunch of variables that you can change, you can edit, and these allow us to tweak how our game looks, plays, or feels. You changing any of these values inside of the student edit zone will not break your game. Your game should still run. It will run. It will just run differently. But be aware, there's an end of the student edit zone. So once we get out of the student edit zone, anything outside of here could potentially break your game if you don't change it correctly. And we're going to work outside of the student edit zone quite a bit. But we just got to make sure that we work together out here. So what's out here? Well, it looks like we defined some gameplay variables. All right, so we're going to have to look at these. Like we got something called a player variable, an aura diameter, and then we enter these things called functions. So functions are going to be super powerful. We're going to make our games with function-based programming, functional programming. And essentially, imagine a function is like a bunch of code that you can run over and over and over again. So inside of this function called setup, I have 3 lines of code. Well, what if I needed to run those 3 lines over and over again? I'd have to type 3 lines, then 3 lines, then 3 lines, then 3 lines. That would be like, what, 3, 6, 9, 12 lines of code I have to write. Instead, I can write these 3 lines once and put them inside of a function. And then I just call that function. So a single line of code saying like, hey, run the setup function will execute all 3 of these lines. So that's going to be extremely helpful for us. And we've got lots of functions here. And let's just go look at what these functions are. So we have a setup function and a draw function. Now, these are crucial functions for our game development. These are from that P5 JavaScript library that we imported at the start of our program. So these are pre-made for us. We can fill them in with whatever we want, but they have pre-written definitions. The setup function will run once at the start of our game. So when I reload my page, as soon as I reload my page, the setup function gets called. As soon as I reload my page, the setup function gets called. This is what the P5 library is doing for us. And if we look, what are we doing inside of this function? We're creating a canvas. This is my canvas, the thing that I'm drawing on. We're setting our text for our text font, and we're calling some function called reset game to defaults. So this is us calling another function. We'll go look at that in a moment. We also have a draw function, which is given to us by our P5 library that we imported. This runs every single frame of our game. So every frame of our game, that function gets called. So every frame, as I'm playing this terrible, terrible game, that function is getting called. So what is it doing? It's getting called, like if our game is running at 60 frames per second, this function is getting called 60 times in 1 second. And it looks like we're calling some functions: update player and draw scene. So let's just kind of go and look. These are functions that we personally will write. These are not part of the P5 library. These are our own functions. We have a game called reset game to defaults. We have a function called reset game to defaults. We have a function called update player. We have a function called get input direction. We have a function called draw scene, which is calling draw background, draw arena, draw player, draw HUD. So we got quite a bit of functions here that we can work with. But I want to stress the nature of these functions. It looks like we have a lot of functions that draw things, right? So we have draw player, draw background, draw arena, and it looks like we have a few functions that are updating things, like get input direction is maybe like updating our player's direction, and we have an update player. And then if we go back to our student edit zone, we have like some places where we're sort of like defining values, right? We're defining like player radius is 18. And we're going to approach game development here through 3 layers. We have to work with data. So the first thing we're going to do is we're going to define our data. Here I am defining the data. The next thing that we'll do is we will update data. So inside of like the update player function, I am updating data. And then the third thing that we're going to do is we will draw data. So down here in one of my draw functions, I'm drawing the player, so I'm drawing the data. Define data, update data, and draw data, the 3 layers of our game development journey here. So, all right, so with all of that said, we now have an overview of what is in this file. So when we start making some changes here, you are not going to be completely lost. Let's move to mission number 1 in our mission checklist. It says we got to change the background color of the arena. Yeah, that background color is not suiting the mood of Bot Bash Arena, right? This doesn't feel like an arena shooter. This looks like I don't know, like an Easter egg hunt maybe with those nice purple colors. So when we approach our mission checklist, mission 1, how do I find where I need to go change that code? Well, mission 1 right here is a tag. So if you hit Control F, you will open up a search bar over here, and you can search for that tag, mission 1. It will only appear twice in this code, once here in the mission checklist, and then if you press these arrows, it will bring you to the previous version or the next version. So if I click the down button, it takes me right to mission 1 in my code, background color. We got to change the background color of the arena and observe how it changes the mood of the world. Now, anytime we start here, I always like to say or figure out where are we in the code for this mission. Well, it looks like I have this weird line where I'm assigning a value, I'm defining some data, and the background color doesn't seem like it should be something that would break our game. So this is right inside of our student edit zone. We are free to make a bunch of changes here. So let's make some changes to the background color. But if we look here, there's like a lot going on in this line. I got const bg color equals, and then this weird thing right here. So let's break it down one step at a time. A const is a constant variable. When you declare something as a constant, it means that once you define it over the area where that variable lives, it is not going to change its value at all. And in our case, once we define the background color of our game, right? I define it and it runs, the background color is never going to change. So it's always going to be constant. So that's where we declare it as const. Then we give it a variable name, bg underscore color. When you have constant variables, the general convention is that you make them all capital letters. So bg color, background color. A single equal sign assigns a value to this variable, and then here is the value that we are assigning. Now this is a weird thing inside of quotations. Anything inside of quotations is known as a string, all right, as a string. And we're going to talk about strings quite a bit, the string data type. Now, this is a special string. This is a special string known as a hex string. And it's a hex string because it has that hashtag or pound sign here. This is a way to represent color. And And there are actually 3 colors in that hex string. There is red, there is green, and there is blue. R, G, and B. There are 2 digits for red. So right now, our red channel is BB. There are 2 digits for green. Our green channel is 44. And there are 2 digits for blue. Our blue channel is CC. So CC. Now, what are those values? Those are hexadecimal numbers. Now, let's talk a little bit about what hexadecimal numbers are, and then we will change this color. Regular numbers, decimal numbers, the numbers you are used to counting on. We can say, start at 0. We go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I run out of digits, right? There's no more digits here. So what I do is I start over, but instead of starting at 0, I start at 1. And I add the first digit, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, right? 1, 6, 1, 7. We understand how to count in decimal numbers. A hexadecimal number system is exactly the same, except instead of having 10 digits to work with, like 0 through 9, we have 16 digits to work with, 0 through 9, and then the letters A, B, C, D, E, and F. So in hexadecimal, we start counting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then before we ran out of digits, so we had to go back to the beginning and shift, right? But we still have digits here in hexadecimal. I have A, I have B, I have C, I have D, I have E, and I have F. But now I have run out of digits. So what do? Well, I go all the way back to the beginning, and instead of starting at 0, I start at the next number, 1. 1, 0. So 16 in hexadecimal is 1, 0. 17 in hexadecimal would be 1, 1. 13 in hexadecimal is the letter D. And we could continue building this out and out and out and out, okay? Now, in terms of color, you have a range of 0, 0 in hexadecimal, which is 0. Give me 0 red, all right? Give me 0 green, give me 0 blue. And then we also have, we can go up to FF, which is a decimal value of 255. And that means give me all of the red, give me all of the green, or give me all of the blue. So right now, if you look at it, we have a BB in the red channel. That's quite a bit of red. And we have quite a bit of blue and a little bit of green. So this should be like red and blue. This should be like a purplish color. And we see that purplish color right here. But boy, is that an ugly color. So let's change it. Let's get rid of all this so we can actually run our program, because that would crash our program if we didn't. And let's just mess around. Let's just see. Let's do all of the red, none of the green, none of the blue. So this should just be a nice red background. Refresh the page, and we see that red. Perfect. Looks great. Let's do a different color. Let's do all of the red and all of the blue. This is going to be that purple color. All right, let's lower these values. Let's do like 8, 8 and 8, 8. So now what's going to happen here? All right, so it's changing that color nicely. Let's see what happens if I do all of the red, all of the blue, and all of the green and all of the blue. So I want all of the colors. Well, you do all the colors, that makes white. So that sort of looks kind of cool. What if you do none of the colors, right? No red, no green, and no blue. Well, that makes black. All right, so let's see. Let's actually pick our color here for our background now. So I'm going to do 1E in the red channel, so a little bit of red, not a lot of red. 2, 2 in the green channel, just a little bit of green, not a lot. And then 2, 8 in the blue channel. So again, a little bit of red, a little bit of green, a little bit of blue. And what color is that going to give me? Well, it's going to give me like this neat little steel color. And that's sort of exactly what I'm looking for my background. All right. So I'm very happy here with mission number 1. Mission number 1 is done. We are in the books. So now we have an understanding of how color works. Let's leverage that understanding for some of our other missions. Let's go to mission number 2. So I'll hit Control F to open up my search bar. And we are going to increase the grid spacing to change the arena layout. All right, so I hit the next down button and it brings me to mission number 2. All right, increase the grid spacing value and watch how the arena layout changes. So it looks like we've got another constant variable here, right? Constant grid spacing is currently equal to 20. So we're defining our data. This is definitely in our, we're here in our student edit zone. So right now it's set to 20 and our grid spaces are pretty close together. What if we made it like, I don't know, 10? Whoa. That's way too tiny. Oh, that hurts my eyes to like look at that. Let's make it much bigger. I don't know. Let's set it to, I think 80 is going to be a nice number. Let's set it to 80 and see what we have. Ooh, that looks pretty cool. All right, I'm liking our layout here. Our layout's coming out nice. Our player is still terribly slow, and the player doesn't really fit our new mood that we set with like this steel background. And I like how these dots sort of look like rivets for a steel arena for fighting in. Mission number 3. Oh, look at that. When we go to mission number 3, it is going to have us fix our player's speed. So right now, it looks like we want to increase the player's speed value and observe how movement responsiveness changes. Well, right now it's set to 1. I mean, ew, that's a terrible value. No wonder why we're moving so slow. And if we look here, there's a little comment. It says we are going to measure this speed in pixels per frame. So how many pixels are we going to move each and every frame? We talked a little bit about frames. Perhaps our game is running at 60 frames per second. So in 1 second right now, my player is moving 60 pixels. But that is too slow. I'm going to change that, and I'm going to change it to 5 pixels per frame. Let's see how this feels. Maybe you like it. Maybe you don't. You can change it to be whatever you want here in the student edit zone. For me, that's some nice responsiveness. I have some nice horizontal movement. But vertical movement is busted. So we're going to have to fix that vertical movement at some point. Maybe that's what mission 4 is going to have us do. So let's head to mission number 4. Oh, that's mission number 5. Mission number 4. Mission number 4. Ooh, we got to change the player's visual identity, because we had said, yeah, you know what? With this new like industrial steel battleground that we have, this player just doesn't fit with what we're trying to go with. So we got to change some of their colors. And it looks like we have a variety of colors here for the player. We have an aura color, a body color, a faceplate color, and an eye color. So the aura is this probably purple thing that's sitting out there. There's our body color, our faceplate color, and then that eye is that center little dot. Now, if you notice, one of these colors is not like the other. The player aura color is not defined as a hexadecimal string using hex values. Instead, it is defined as an RGBA string or RGB alpha. Typically, anytime I want to have a color that has transparency that you can see behind, I write it as an RGB alpha string. RGB alpha strings take 4 values. They take a red channel, a green channel, a blue channel, and then an alpha channel. Now, the red, the green, and the blue work just like hex strings, but instead of doing 0, 0 to FF, like 0, give me none of the red, FF, give me all of the red, you use decimal numbers. You would do 0, give me none of the red, to 255, give me all of the red. Now, let's change some of these values right now, because I don't like this like purple look that we've got going on. So in the red channel, I'm going to have 76. So I'll take a decent amount of red. I want all the green though. So 255. Give me all of the green, and we'll keep the blue channel at 178. So let's see what this color is going to look like. Ooh, I like that color a lot more. That looks pretty good for me. Now that last number is the transparency, the alpha channel. If I set it to 1, it means it is not transparent at all. You cannot see behind it. Like right now, I don't see that rivet at all. If I set it to 0, it means it is fully transparent. It means you're going to not see anything. You're just going to see behind it. All right, so now it's completely gone. But if I set it somewhere between 0 and 1, I can get transparency. So I'm going to set it to 0.4, 0.4. And so now that means I'm going to be able to see a little bit behind it. And there you can see those rivets still behind there. And I think that's a really great effect for an aura or a shield that our player has. We should be able to see behind it. All right. So now we've got our aura color. Let's change our body color. I'm going to get rid of the hex string that we have here, and I'm going to say in the red channel, I want a fair amount of red, 9A. And in the blue green channel, I'm going to put A4, a lot of green, and AD in the blue channell. So 9A, A4, AD. And if we refresh, there we have it. We got that nice looking color right there. So 9A, A4, AD for our body color. Let's change our faceplate color now. So our faceplate, I want this to be, let's see, 5C in the red channel, 6 in the green channel, 7 in the blue channel. So let's update that. Ooh, and that gives us like a nice steel. Now it's really starting to look more like a robot. But then lastly, I got my eye. I'm going to change my eye color. So that center little point that's going to be looking at us. We'll make it 4C FFB2. Think for a second. What color do you think that might look like? Well, we got only a little bit of red, all of the green, and a fair amount of blue. Let's think for a second. Ooh, that looks really cool. And that sort of matches the aura color. So we got lots of green, lots of blue. That's going to make like a nice cyan color. Our aesthetic of our game is coming along nicely. How it looks, the mood we are getting. So let's head to mission number 5 now. Mission number 5 is about connecting our input from our keyboard to our player. Because right now we know, hey, our player is not moving vertically. So something is off in our movement system. So this puts us in a function called getInputDirection. Let's look at what is inside of this function. Well, the first thing, we have 2 variables here, dx and dy. But if you notice, we're not declaring them with const. Then they're not capitalized. And this is because these are not constant variables. We are going to change the value of these variables as they exist inside of this function. So when you have to change a variable, you use let to declare it. Now, how are we changing these? Why are we changing these? Well, we want to get the input direction. We want to check to see if the user is pressing the left key, the right key, the up key, the down key, or W, S, A, and D. And then we want to move our player accordingly. So if we look here, we introduce a brand new concept known as an if statement. An if statement is our way of getting to ask a question. And if the answer to the question is yes or true, we are going to run some code. So if you look, we are asking a question with an if statement. And the question that we ask goes inside of our parentheses. So let's break down what's inside of this set of parentheses for this question here. So it says key is down 65, these 2 vertical bars, and then key is down left arrow. So what is this asking? Well, key is down is a function that is going to check whether or not a key is currently being held down. What key? Well, you put the key in here. So this is checking if the left arrow key is being pressed down. These 2 vertical bars mean or, okay? And we're actually checking to see if a different key is pressed down. Key 65. Every key on your keyboard has a key code, and 65 is the letter A. So essentially, this question is asking, is the A key being pressed down, or is the left arrow key being pressed down? And if the answer to that question is yes or true, this little bit of code right here is going to run. And what we're doing is we're taking that dx variable, which was set to 0, and we are subtracting 1 from it. So now it is -1. What does that -1 indicate for us? It means we want to move to the left. So we're moving to the left. We have another question, though. We say, hey, if key is down 68, that is the key code for D, or key is down right arrow. So are we pressing the D key or the right arrow? If that's the case, we're going to take our dx variable. Instead of subtracting 1, we are going to add 1 to it. So instead of being 0, it will be +1. So +1 in the x direction is going to move us to the right. So it looks here, dx is +1. Here, dx is -1. And if I'm not pressing any key, then what is dx? Well, when we run this function, dx is going to start at 0, so we're not moving. So we need to mimic this now in the vertical direction. All right, so let's ask a question. We're going to say if, a parentheses, and my question is going to go in here. So we're going to ask a question, and then we're going to look at if the answer to that question is true. I now want to target not my dx variable, but I'm going to target my dy variable. So the question that I'm going to ask is going to be, key is down. I'm going to check to see if a key is down, some key, or key is down, another key. So we are going to do, let's do the up direction first. So I'm going to say up arrow, and then for WASD movement, we want the W key. So the W key has a key code of 87. So if the W key or the up arrow key is being pressed, we want to move up the screen. So we are now going to target this dy variable, which is currently 0, and we're going to set it to dy, and we're going to subtract 1 from it. And here's the reason why. A lot of times students are very comfortable saying to the left is negative and to the right is positive. But in video game development, going up the screen is negative. And the reason why is when we define our screen's dimensions, the left side is a horizontal value of 0 and the top is a vertical value of 0, such that this top left corner right here where my mouse is the point 0, 0. So going up decreases our y value, going down increases our y value. All right, so that line is set. So now we got to do it for going down. So let's say if, we'll ask a question, key is down, and we are going to check for the S key, which has the key code of 83. Or key is down, and we'll plug in the down arrow. All right, and if that is the case, we want to alter that dy variable, but this time, instead of having it be -1, we're going to make it +1 to indicate that we want to go down. Let's run this. Let's see if we got our vertical movement in place. So to the left, to the right, up, and down. Hey, and I can even go diagonal. This is great. All right, so hey, if it looks like I hit the wall and I'm stuck here in the vertical direction, so that's kind of cool. But in the horizontal direction, bye-bye, see you later. I can just leave. And so this is not good. That's actually pretty bad. So we got to fix that, and we will. I'm sure we will. But before we get to that, let's just see. There's this really important line of code here at the end of mission 5. We didn't have to write it, but we have to understand what it is doing. At the end of this function, get input direction, it says return, and we are returning this thing inside of curly brackets. Something inside of a curly bracket is an object, all right? So we are returning this object. Where are we returning it to? Well, we're returning it to wherever this function was called from. So I'm going to just scroll up a little bit, and if we look at our function called update player, we are calling that get input direction function. And see how we're setting it equal to a variable called move direction? So when we say, hey, call this function, that function gets our input from our keyboard and then returns the value of dx and dy. And that object gets stored in this variable move direction. So move direction now has two parts to it. It has those two properties, dx and dy. And if you look, we're setting a dx property of move direction and a dy property of move direction. What else is an object? Our player is an object. So I'm just going to go back up to our I'm going to scroll down. Here we go to our gameplay variables. I got these gameplay variables called arena left, arena top, arena right, arena bottom, and then I have a player. And this player object has two properties, an X property and a Y property. And you can change those properties to position the player anywhere in our gameplay world. So let's go to mission 6 now and see how this all ties in together. Because in mission 6, we're creating a variable called move direction by getting the dx and dy values from our get input direction function. And then we're updating the player object's X property. So player dot X. Think of that dot like, give me a list of everything that you have, and I'm going to select what I want. I want your X property. And we're adding to it whatever the move direction is in the dx value. So this is either going to be -1 if we're moving to the left, +1 if we're moving to the right, and 0 if we're not moving horizontally at all. So -1 or +1 or 0, and we're multiplying it by our player speed, which is 5. So we're going to add to our player's X position either +5 pixels, -5 pixels, or 0 pixels. And we do the same thing in the Y direction. So this is pretty nice using those properties of our objects. But then we come here to mission 6. It says constrain the player horizontally within the arena. Use the existing pattern to complete the missing axis. So we know we're not constraining on the X axis. It looks like we're bounded on the Y axis, right? I can't go off the screen in the Y axis, but I can go off the screen in the X-axis, so we don't want that. So to constrain something means take a value and fix it between a lower bound and an upper bound. That's what it means to constrain. And so I want to constrain the player's X property. And so to do that, I'm going to target player.x, there's their X property, and I'm going to call the constrain function. This is going to take 3 pieces of information. First, it's going to take in the value that you want to constrain. I want to constrain the player's X value. So go see what is the X value currently, and then you present the lower bound or the smallest value and the higher bound, the highest value. So I don't know, what if I just do like 0 as our lowest? So that's going to be the left side of our screen, and then width, which is the width of our canvas. So let's just see what happens here now. If I refresh the page, my player can zoom, zoop, hey, and they're stuck here. Well, they're stuck at an x position of 0. X for our circle is the center of our circle, and it moves all the way to 0, which is way over here, right? But I want to get them stuck here. So that's not quite right. And then the same thing is probably going to happen, yeah, over here. So we got a little bit we still got to do here. Let's work with those arena variables that we saw. So where were those arena variables, right? Look, we got arena left, arena right, arena top, arena bottom. I think we need to work with those because in reset game to defaults, it looks like we're setting them equal to some constant variable. How do I know this is a constant? Well, it's capitalized and it's got a value of 80. So like 80 pixels in. So let's actually work with that. Let's actually work with that here. So instead of doing 0, let's do the arena left variable. All right, so let's put that in. Let's see what happens now. So now when I go zoop, hey, I'm constrained here to the left side of the arena instead of the left side of the world. But it's the center of my circle. So really, I want to move back in by like that amount. So that amount that I'm going to move back in is the radius of our circle. So I got to move back to the right. So I'm going to add my player's radius. Now here's a nice thing. Once you start typing, you get a list of all these great things. If you go to the one you want, you can hit tab to autocomplete, which is super cool. And since we did this arena left plus player radius, let's do something similar here. Instead of going all the way to the width, let's do, because this is going to be the right side of our arena, right? This is the right side of our arena. We're going to do arena right. And instead of adding the player radius, by the time I get all the way over here, instead of adding the player radius, I got to subtract it, bring it back to the left. So we're going to do minus player radius. Tab for autocomplete. Hey, look at that. And this mimics our Y constraining quite nicely. So now I should have really great constrained bounded movement inside of the arena. Our poor little robot cannot escape. They're going to have to fight. But before they fight, we have 2 more missions we got to solve. Mission 7 says adjust the arena wall boundaries. All right, let's hit the down arrow. And this puts us in this really great function called reset game to defaults. Anytime we restart our game, we want to take all of our values and make sure they're back to their starting values. So if you look here, we are defining those variables: arena left, arena right, arena top, arena bottom. And it looks like some of them are pretty good. Like I like the margin here. I got good margin here and here, but I definitely don't on the right side. So we got to fix that. So let's see what the arena right is. Well, currently it's just the width of our canvas, the width of our screen. So it's extending all the way over to here. And that makes sense. It's butted up, but I really want to put this padding here. So I'm going to shift the arena back. And how much am I going to shift the arena back by? So width brings me all the way to the edge of the screen. So then to shift back, I do a minus sign, and I'm going to shift back by that constant arena margin. I can go down to it, tab to autocomplete. So now we're going to shift it back 80 pixels. Boop. And now our arena looks centered in the screen. That's much better. And if we look here, we also, what do? We reset our player's X position and Y position so that it's centered in the screen. Width divided by 2 centers us horizontally. Height divided by 2 centers us vertically. So that's kind of nice there, right? Like if I change these to, I don't know, like let's just say 100 and 400. Now when I restart the game, we're starting 100 pixels in, 400 pixels down, but we don't want to start there. So Control Z to change that. All right, mission number 7 is done. We just now got to look at mission number 8. Mission number 8 is all about our HUD's identity. We're going to change the game title text. Give your version a custom name if you want to. So right now, this is in a draw function, our draw HUD function. Let's just look at what we're doing here. We're calling a function called no stroke. That means give me an invisible marker so you don't see the shape that I'm about to draw. And then we put paint in our paint bucket, and we fill our paint bucket with a variable called HUD BG color. It's black. It's an RGB alpha string, 0, none of the red, 0, none of the green, 0, none of the blue, with a transparency. And then we draw 2 rectangles. We draw 1 rectangle at the top of our screen and 1 rectangle at the bottom of our screen. The rectangles need 4 pieces of information. This is the upper left corner of the rectangle. So 0, 0, boop, right there. And then this is the width of the rectangle, the width of our canvas, and then height of the rectangle. So our height is 60. So it says, hey, start here in the upper left-hand corner, draw a rectangle that's as wide as the screen and only go down 60 pixels. So there is that top HUD, and then we repeat that for our bottom HUD. And then it looks like we change our it looks like we are changing the paint in our paint bucket, and we're filling it with the arena border color, which is this orange color, which we're mimicking with our text. And then we're aligning our text. We're positioning our text so that in the horizontal direction, it is centered, and in the vertical direction, it's centered. And then we set our text size to 24. So if I change this, I don't know, like 90, our text should get a lot bigger. Whoa, game name, way too big. Let's change it back to 24. And so then once you get all that set up, right, and we're going to look more at that later, we create a text, we call it text function. This takes 3 pieces of information: the text that you want to show as a string, its X position, and its Y position. So right now, let's change this from game name to bot bash arena. And it looks like we're positioning it width over 2, so centered horizontally, and then HUD height over 2 means centered vertically in our HUD. And there we have it. Man, I remember what this thing looked like at the start of this video and what it looks like now, and it looks like a completely different game. And it's pretty fun controlling this bot all over the arena. All right, I think this is a great place to stop. We did some wonderful work here in terms of overviewing our HTML file, the P5 JavaScript library that we imported and brought in, and then working with our own JavaScript code to define data, update data, and draw data. Our world is set. Our player is set, and we can continue to build out our world and the functionality of our player in upcoming videos. So I'll see you then.